All right. Hi, guys. Welcome to our seventh lecture, where we are going to discuss the electromagnetic radiation and the electromagnetic spectrum. Now, in our last lecture, we discussed about the electromagnetic force, where we talked about areas where we experience electromagnetic force. We said that electromagnetic force is experienced between charges of particles of the same charge and particles of unlike charge. So it means that both repulsive force and attractive force are all electromagnetic force. We also say that electromagnetic force is experienced through the poles, and we highlighted that the difference between a magnet and our charges are that they possess energy in discrete, whereas the magnet exists in dipoles. Now we looked at areas upon which we can apply the electromagnetic force to our advantage, where we talked about the step-up transformer, where we supply a low energy voltage and then we step it up to a high energy voltage, both for the industrial machinery use or healthcare machines like the X-ray machines. Now today we want to take a voyage into electromagnetic radiation and electromagnetic spectrum. Now, electromagnetic spectrum consists with a certain number of members. As you can see, we have our radio wave, we have microwave, we also have our infrared, we have our visible light, and then we have our ultraviolet light. Then we also have our X-rays here, and then we have our gamma rays. As you can follow with me within this, you can see the difference. Now, the members that appears up, you can see the difference. They are having longer wavelength. Their wavelength is longer, and their wavelength, because their wavelengths are longer, then it means that the penetrating power is low, and this one is contributed by the fact that they have low frequency. Now, the members of the electromagnetic spectrum, starting from the ultraviolet light, are non-ionizing radiations, whereas the members from X-ray and gamma are ionizing radiation. They are ionizing radiation because they possess sufficient energy that can dislodge an electron. Now, there's another property. There's a property of ultraviolet light that we cannot underlook. Now, this property not really ultraviolet, but the visible light that we cannot overlook. That the visible light can be used within the spheres of treatment if properly tapped, and the story has been how it can be tapped to be used in to cure HIV and AIDS, because it is realized that to some extent this genetical makeup of HIV and AIDS cannot withstand that type of light. So only that how it can be used to realize that advantage is becoming a problem. Otherwise, it's an application that is under that researchers are working on it to see how it can be realized. Now we are saying that as you go down the spectrum at around 700 nanometers, which we get our visible light. And as you can see, our visible light is separated, it is dispersed into our common 7 colors. Now, below that we have ultraviolet light. That ultraviolet lies within 400 nanometer of wavelength. But now the members of the spectrum with the wavelength below 400 now become ionizing. They are ionizing radiations because their wavelength they have a shorter wavelength. And whenever they have a shorter wavelength, clearly they are going to have a high frequency, because when you check at the relation between frequency and the wavelength, then they experience indirect proportionality. Now, the members that are up are not able to ionize. Reason being, they have low energy. The energy that they possess, even if they interact with matter, they cannot dislodge an electron, and therefore the energy they have is not sufficient for ionization. They can't really ionize an electron, they can't ionize matter. But these members, the two members, the gamma and the X-ray, are able to ionize. Now, another factor that we really need to know is that as much as X-ray and gamma are able to ionize, X-ray here is able to, it has high ionizing power as compared to gamma, whereas gamma is having high penetrating power as compared to X-ray. Now, X-ray is able to ionize by the fact that its speed, it moves very, very slow. It is heavier, it moves very slow. The frequency is very slow. Of course, the one thing we have to agree on is that all these members of the spectrum move at the same speed, but they possess different energy. So the energy it possesses is very low, and therefore it will not penetrate as fast as we expect the gamma to do the penetration. In other words, it will be highly attenuated. Let me use that term. It will be highly attenuated because it takes time to interact with matter, as compared to gamma. Gamma will penetrate because it has high energy, and the high energy possession is contributed by the fact that it has shorter wavelength as compared to X-ray. Now, the wavelength of the X-ray is longer as compared to the wavelength of gamma. So, frequency of gamma is higher. Now, the frequency of electromagnetic spectrum increases down. As you move down, the frequency increases. And if the frequency is increasing down, then it means that the energy penetrating power is increasing as you go down, whereas the wavelength increases as you go up. And when the wavelength increases, then automatically what we expect is a low energy possession. Now, the construction of electromagnetic wave, normally they are transverse in aspect. In other words, they move at right angle with the direction of the motion. As you can see, it moves up and down with the direction it moves up. So it means that at every point there's a particle that is moving up. There's moving down. So these particles, when constructed, it gives an orthogonal kind of orientation. Now, this energy, the energy that is possessed by this kind of particle, is obtained through the help of the Planck's constant and multiplied by this Planck's constant multiplied by the frequency. But again, the speed with which this kind of element moves is also of great importance, as it is able to tell us the wavelength. Now that we know that the speed is constant, and the speed, we see that all the electromagnetic members of the electromagnetic spectrum moves at the same speed of light, that is 3.0 times 10 raised to the power 8. Now, when we look at this relation, then clearly it tells you that for us to make this constant, then we have to manipulate the two, to the extent that if frequency is high, then wavelength has to be low for us to realize a constant speed. Now, if wavelength is high, then frequency has to be low. And when the frequency is low, then we are going to suffer the problem of low energy. Because if we express this in terms of, if we express energy in terms of speed, then you realize that lambda is inversely proportional to the energy. When lambda increases, energy reduces, and when lambda reduces, energy increases. Now members, up to this point, we have completed the first section of our radiology physics module. We have managed to discuss the atomic particles, the subatomic particles. We also talked about the properties. Now it is our pleasure now to move to the next section of radiology physics. We are going to do the X-ray physics. Here we shall discuss more of electron production, how it's being accelerated, being produced in the filament, being accelerated, how it hits the filament, how it hits the target anode, and then produce the X-ray that we use in the hospital. And we shall not stop there. We shall look at how those X-rays are being manipulated to the realization of the image formation. Thank you very much, and I welcome you to our next lecture that will be on Introduction to X-ray Physics. You can, I wish to ask you to subscribe and maybe hit the bell button so that whenever we upload any video or any lecture, you'll be able to follow up. Thank you. Have a nice time. See you in the next lecture.